السلام عليكم أصدقائي الطلاب. Welcome to Chemistry Online with Mr. Ahmed Suleiman. Today we are going to study the second lesson, which is hydrogen ions and acidity. You remember when we studied the meaning of acid and base according to three theories. The last one, which was Lewis theory, was the general one. It can explain any ion or molecule, whether it is an acid or base. You remember that we explained the main idea of acid. So how are hydrogen ion concentration and hydroxide ion concentration related to the aqueous solution? That's what we're going to study today, and how can we calculate this concentration for each of them to identify if the compound has an acidic effect or basic effect. Remember, hydrogen ion and hydroxide ion are related to each other because they form water compound or water molecule. You have to know something. Water molecule is a high polar compound or molecule, and it's in motion all the time. So the molecules of water are highly polar, and also they are moving in a constant motion, even in room temperature. It means if you have some water in a cup, sure, they are in motion, the molecules are in motion. Look at this equation. Water molecule reacts with water molecule. It means some water altogether. If you imagine two molecules of them, if they are in the same container, they are highly polar, as I said, and also they are in motion, as I said. So they react together in reversible reaction and form hydronium ion and hydroxide ion. What does it mean? It means one hydrogen ion here and hydroxide ion here ionized, and one of these ion, which is hydrogen for example, moves to this water and forms hydronium. The other one, which is hydroxide, will be used from the reaction as product. So water and water produce hydronium ion and hydroxide. Recall, hydronium ion is the same as proton, as I said before. Remember that. Water molecule gains hydrogen here, as I said, and becomes hydronium. The other water, when it loses this hydrogen, it becomes hydroxide. That's what we said now. What happens after that? We formed two ions. One hydronium, or we can say hydrogen ion, and the other hydroxide. This process happened to the water, and at this time we can call it self-ionization of water. It means the water is ionized by itself without any interference. The reaction here produces ions, two types of ions. It means what happens is self-ionization of water. Hydrogen ions always join to water, as I said, to form hydronium. Now, if you want to know the concentration of each of them, hydrogen ion and hydroxide, the pure water at normal temperature, which is 25 degrees Celsius, the concentration of hydrogen ion is 1 times 10 to the negative 7 molar. This is for hydrogen, positive. What about the concentration of OH hydroxide ion? Also the same value, 1 times 10 power of negative 7 molar. Why? Because the number of hydrogen ion equal the number of hydroxide ion. They are equal in a pure water. And the aqueous solution of both of them called neutral solution, because it's neutral. They are equal in numbers, equal in their concentration, so the solution is neutral. What happens to the water, and what's the relationship between what happened to the water in container and the Le Chatelet we studied before, Le Chatelet principle? You can apply the Le Chatelet principle in the case of ionization of water. How? Look, if you have like this hydrogen ion and this hydroxide ion in aqueous case, they form water. You can apply Le Chatelet because this reaction is reversible reaction. It means, as we said, water can be ionized by itself into hydrogen and hydroxide again. So the reaction is reversible reaction. If you increase the amount of water, that means the reaction shift to the left, and if you increase whether hydrogen ion or hydroxide ion, the reaction will move forward at this time, because I'm talking about the concentration now. So the equilibrium will shift toward the formation of one of them according to what you add in the reaction. Ion product constant for water is K. Remember when we studied the constant equilibrium for any reaction, reversible reaction? I want to say something. Look, we have here aqueous, and liquid. What we said before is if you want to calculate the K equilibrium for any reaction, you have to deal with gases. If something liquid or solid doesn't affect the equilibrium, it means if you have X in the case of gas, for example, plus Y, gas also yields Z, liquid. If you want to calculate the equilibrium for this reaction, so the product concentration first, Z, like this, must be like this. And the reactants concentration here, the coefficient, if the coefficient is 1, okay, no problem. If the coefficient here is 2, for example, here 1, here 3, so you have to make 3 here and 2 here, power 2, nothing here because it's power 2, 1. It's like this. No, something wrong here. Why? Because one of the compounds, not gas, here is a liquid. So you cannot write this. So the correct answer is K equilibrium here equal 1, nothing here, 1 over X squared concentration times Y concentration, like this. Why? Why we cannot calculate or put the concentration of something liquid or even solid in the reaction? I mean طبعا reversible reaction here. Why? Because the concentration of any liquid or solid is constant during the reversible reaction. Constant. No change in the concentration of any liquid or even solid. So we cannot write any concentration because it doesn't affect the equilibrium at all. For this reason we are doing like this. Okay? طيب. What if the molecule, the ion, is not liquid but aqueous solution? Yes, we can use it and we can calculate the concentration. Look at this equation again. We have aqueous solution here of hydrogen. We have aqueous solution of hydroxide, so we can apply them in the equilibrium constant. But this is liquid. You can't do that. Why? Because it has constant concentration during the reaction of reversible. So if you want to do the equation for equilibrium, so K equilibrium here equal the product, which is H2O. No, it's liquid, so it's 1. Divided by the concentration of hydrogen or hydronium, the same meaning, power 1 times OH, like this. Ion product constant for water is constant. They calculate the value of them and they found that it's 1 times 10 power of negative 14. This is a K equilibrium. Look, they imagine that hydrogen and hydroxide ions are released from the equation like this. H2O in reverse reaction produces H positive or hydronium, whether this or that, and the hydroxide ion. If you want to calculate the K equilibrium here, equal the product H positive times the concentration of the product OH divided by H2O, which is constant, I know. Because it's constant, they multiply it with the K equilibrium, which is constant as well, and they called it KW, means constant, new constant for water. So KW equal H positive times OH negative. They calculate this constant and found that it's 1 times 10 power of negative 40. Okay? This value. Ion product constant for water, which is KW here, I told you, and has this value 1 times 10 power of negative 14. If you want to define this, what does it mean? The ion product constant for water is the product of concentration of hydrogen ion and hydroxide ion in water. That's what happened in the equation I explained, and we called it KW. Now we need to apply this in an equation like this. If you have like this equation, HCl aqueous solution dissolves in water and ionized into hydrogen ion aqueous solution and chlorine ion aqueous solution. Someone asked me, where is the water here? It's aqueous solution. It means water is in the solution, aqueous. Okay? Hydrogen ion concentration here is greater than hydroxide ion. Well, hydroxide ion is not appeared here, but water is in the solution. So there is a hydrogen ion or many hydrogen ions in the solution. But it's not more than hydrogen. Hydrogen is more or greater. So the solution here, if it has hydrogen ion greater than hydroxide, it means it's an acidic. And the concentration of hydrogen is greater than this value. I told you the KW, which is the multiplication of H positive times OH negative, equal 1 times 10 power of negative 14. Yes. So, and I told you the concentration of OH equal to the concentration of H positive. So, if this value divided by 2 of them, so the concentration of H positive equal what? And the concentration of OH equal what? 1 times 10 power of negative 7 and 1 times 10 power of negative 7. Okay. So the hydrogen here is greater than, the hydrogen in the neutral is 1 times 10 power of negative 7. But here hydrogen is greater. So the concentration is more than 1 times 10 power of negative 7. Maybe 1 times 10 power of negative 5, maybe 1 times 10 power of negative 4, whatever. Okay. What about a basic solution? If you have basic solution like this, when sodium hydroxide dissolves in water, NaOH aqueous, it produces sodium ion aqueous solution and the hydroxide ion aqueous solution. Hydrogen here, not a lot, but hydroxide appears here. So the concentration of hydroxide is more than hydrogen. Or we can say hydrogen ion is less than hydroxide ion concentration. This is the meaning of basic solution. It means basic solution is one in which hydrogen is less than hydroxide. Because actually we are using hydrogen even to express the concentration even in acidic solution or basic solution. We are using H. Okay? So in the basic solution, H positive is less than hydroxide OH. How can we use that constant? If you have, for example, H positive in a solution has this amount of concentration, 1 times 10 power of negative 5. The solution is acidic, basic, or neutral. Look, this value is greater than 1 times 10 power of negative 7. The value of concentration of hydrogen is 1 times 10 power of negative 7 in the neutral solution. But now we have the concentration greater than this value. So it's acidic. Yes? How can we know? If you have like this value of concentration of hydrogen, and you know the Kw, which is 1 times 10 power of negative 14, it's a constant. We need to identify if it's acidic, as I said, or basic. Let's try it as a problem. OH negative, we need to know. If it's high value, it's basic. If it's low value, it's acidic. Let's answer this. Recall the equation we said before, and you can identify that Kw equal the concentration of H times the concentration of OH negative equal 1 times 10 power of negative 14. Okay, now if you want to calculate OH equal 1 times 10 power of negative 14 divided by the value of H you have, which is 1 times 10 power of negative 5. You will get the value of OH. If it's high value, so it's basic because it's OH. If it's low value, it means it's acidic. It will be طبعا low value here, so it's acidic. And you don't need to calculate. Why? Because here the coefficient is only 1, so you can calculate it. If H is 1 times 10 power of negative 5, it means OH is 1 times 10 power of negative 9. Why? Because both of them 10 power of negative 14. Because they are equal. Here 10 power of negative 7, here 10 power of negative 7. If this is not 7 but 10 power of negative 5, here must be 10 power of negative 9. It means low value, lower than this value. It has lower value of OH, it means it's not basic, it's acidic. So you can use this method as well, only if you have coefficient 1. Look, this is the equation I explained, and this OH, if you want to calculate it here, as I said, 1 times 10 power of negative 14 here, and the value you have provided here, 1 times 10 power of negative 5, for example, you can calculate the value here, and it will be 1 times 10 power of negative 9, as I said. Okay, so low value for OH, it means high value of H, it means acidic. This is the end of part 1 of our lecture.